Dr. Pradeep K. Suri's journey with Brain NeuroGov Plus AI. Synopsis. Brain NeuroGov Plus AI represents an evolution from systems engineering and structured analysis to governed cognitive intelligence. The architecture extends traditional concepts such as DFDs, processes, data stores and relationships into an AI-native framework connecting system rightward arrow register rightward arrow data point rightward arrow source rightward arrow data flow rightward arrow AI engine rightward arrow analysis rightward arrow governance rightward arrow decision. At its core, Brain NeuroGov Plus moves beyond the concept of one AI producing one answer toward an integrated ecosystem incorporating the 3D, 10D AI DNN engine, Cognitive Cube, Analyzer 1.0, 63 specialized AI engines, NG001, NG063, registers, data points, sources, DFDs, OCR/image intelligence and enterprise platform services. The next level is governed decision intelligence. The Cognitive Cube provides multidimensional intelligence. Analyzer 1.0 transforms information into structured analysis. The policy engine using set theory applies defined rules and governance constraints, and the cockpit brings intelligence, evidence, risks, explanations and decisions together for human oversight. The resulting philosophy is structure before intelligence, data before conclusions, evidence before interpretation, governance before action, traceability before trust, and validation before acceptance. Thus, Brain NeuroGov Plus is envisioned not merely as 63 AI engines, but as a connected, traceable and governed cognitive enterprise architecture in which AI intelligence, analytical validation, policy governance, and human judgment work together. 1. The journey begins with systems engineering. The story of Brain NeuroGov Plus AI does not begin with ChatGPT, generative AI, or today's large language models. It begins with systems thinking. Dr. Pradeep K. Suri's long experience with systems engineering and structured analysis established a fundamental way of thinking. Understand the system rightward arrow identify its processes rightward arrow identify its data rightward arrow establish relationships rightward arrow trace information rightward arrow control the system rightward arrow produce reliable outcomes. This philosophy later became extremely valuable when AI entered the architecture. The question was no longer simply, can AI generate an answer? The more important question became, can an AI-generated answer be understood, traced, validated, governed, and trusted? That question is at the heart of Brain NeuroGov Plus. 2. From structured analysis to AI governance. Traditional structured analysis provides mechanisms such as data flow diagrams, data stores, processes, external entities, data relationships, system boundaries, information flows. Brain NeuroGov Plus extends this philosophy into the AI era. The relationship can be represented as system rightward arrow register rightward arrow data point rightward arrow source rightward arrow data flow rightward arrow AI engine rightward arrow analysis rightward arrow governance rightward arrow decision. This is not simply digitizing an old methodology. It is an attempt to create a modern AI-native evolution of systems analysis. 3. The birth of the NeuroGov Plus concept. The central idea evolved around a simple principle. AI should not operate without governance. AI can calculate, classify, predict, recognize, summarize, reason, detect patterns, generate recommendations. But an enterprise system also needs to know, where did the information come from? What data was used? How reliable is it? What assumptions were made? What calculations were performed? What risks exist? Can the result be audited? Who ultimately accepts the decision? This created the conceptual space for NeuroGov Plus. 4. Brain NeuroGov Plus the cognitive architecture. The word brain represents something larger than an individual AI model. The architecture is intended to behave as an integrated cognitive system in which different specialized capabilities work together. Instead of one AI rightward arrow one answer, The architecture moves toward data rightward arrow specialized intelligence rightward arrow cross-analysis rightward arrow governance rightward arrow decision intelligence. This creates an ecosystem rather than a single model. 5. The 3D, 10D cognitive cube. One of the important architectural developments is the 3D, 10D cognitive cube. Its purpose is to allow information to be examined through multiple dimensions rather than treating every problem as a single prediction or classification task. The broader concept is dimension rightward arrow perspective rightward arrow relationship rightward arrow analysis rightward arrow intelligence. This provides the cognitive foundation upon which NeuroGov Plus analytical capabilities can operate. 6. Analyzer 1.0. The development of Analyzer 1.0 represents another major step. The objective is not merely to generate information but to transform information into structured analytical intelligence. A simplified chain is input data, downward arrow, data processing, downward arrow, analysis, downward arrow, metrics, downward arrow, risk/variance/performance, downward arrow, interpretation, downward arrow, governance. This is particularly important for enterprise applications where numerical and factual accuracy matter. 7. The 63 specialized AI engines. The architecture subsequently developed into a large ecosystem of specialized AI engines. NG001 rightward arrow NG063. Rather than asking one general AI system to perform every function, Brain NeuroGov Plus can assign specialized responsibilities to individual engines. Conceptually, Brain NeuroGov Plus. Specialized Analytics Governance. AI Engines. NG001, NG063 Analyzer 1.0 Governance Layer. Cognitive Intelligence. Decision Support. The 63 engine baseline therefore becomes a major architectural asset. 8. The emergence of the register architecture. The next major realization is that AI engines need a strong underlying information architecture. This is where the register becomes extremely important. A register can provide a structured representation of a domain, system, process, organization, financial model, risk environment, or other enterprise object. But the register itself is only the beginning. 9. Data points. The next major foundation. The architecture is now moving toward register rightward arrow data points rightward arrow sources rightward arrow DFD. This may become one of the most important foundations of Brain NeuroGov Plus. A data point is much more than a value. It can represent a measurable fact, a business attribute, a financial value, a process state, a risk indicator, an operational measurement, a source-derived observation, a calculated metric, a relationship, a governance parameter. Therefore, more meaningful data points can give Brain NeuroGov Plus a richer representation of the real-world system. This creates a bridge between real-world information and AI intelligence. 10. Sources and traceability. A data point should ideally be traceable to its source. Therefore, data point rightward arrow source becomes a fundamental relationship. The source may be a database, document, spreadsheet, API, financial statement, enterprise system, report, sensor, human input, external information source. This provides the foundation for evidence-based AI. 11. DFD becomes more powerful. Your established structured analysis background makes the next step particularly significant. The traditional DFD describes where data comes from rightward arrow, how it moves rightward arrow, where it is processed rightward arrow, where it goes. NeuroGov Plus can extend this concept. Source rightward arrow, data point rightward arrow, register rightward arrow, process rightward arrow, AI engine rightward arrow, analysis rightward arrow, governance rightward arrow, decision. Therefore, The DFD can become an important visualization and verification layer for AI systems. 12. OCR and image intelligence. The work on Brain NeuroGov plus v9.1 OCR/image intelligence adds another dimension. Documents and images contain valuable enterprise information that is not initially available as structured data. The architecture therefore needs to transform. Image rightward arrow OCR rightward arrow evidence rightward arrow data points rightward arrow analysis. An important lesson from the v9.1 testing was that extraction and interpretation should not be confused. For example, OCR should preserve the verified evidence. AI interpretation can occur afterward, but it should not silently alter authoritative numbers. That distinction is extremely important for financial and enterprise intelligence. 13. Financial intelligence. The financial analysis cockpit demonstrates how the broader architecture can become an operational system. Financial information can flow through financial source, downward arrow, data points, downward arrow, financial register, downward arrow, calculations, downward arrow, analyzer, downward arrow, risk/performance analysis, downward arrow, governed decision. This is where the theoretical architecture becomes a practical enterprise capability. 14. Enterprise platform services. Not everything should become one of the 63 specialized engines. Some capabilities are better treated as common platform services. For example, the global visitor counter belongs conceptually to the Brain NeuroGov Plus enterprise platform services layer rather than becoming another specialized AI engine. This establishes another important architectural distinction. Specialized intelligence. NG001 rightward arrow NG063 versus common platform services. Reusable capabilities supporting multiple NeuroGov Plus cockpits and applications. This separation helps prevent unnecessary duplication. 15. Cockpits. The human interface. The Brain NeuroGov Plus cockpit provides the human-facing layer. The cockpit can bring together data, analytics, AI intelligence, visualization, governance, alerts, explanations, decision support, human controls. The objective is not to remove the human. It is to give the human a better cognitive operating environment. 16. Human plus AI. This leads to one of the most important principles of the entire journey. Brain NeuroGov Plus is not intended to replace human governance. Instead, human intelligence plus artificial intelligence plus governance can produce augmented decision intelligence. The human remains responsible for judgment where human judgment is required. AI provides scale, speed, pattern recognition, and analytical assistance. Governance provides control. 17. Explainability. A governed AI system should ideally be able to answer: what happened? Why did it happen? What data was used? What evidence supports it? How was it calculated? What assumptions were made? What is uncertain? What risks exist? What should the human consider? This is substantially different from simply producing an AI-generated answer. 18. Accuracy and validation. Another important part of the journey is recognizing that AI intelligence must be validated against authoritative evidence. This is especially important when financial numbers are involved, regulatory information is involved, operational decisions are involved, compliance is involved, measurements are involved. Metrics such as RMSE, variance, and other validation measures can therefore become part of the analytical and governance framework. The principle is: AI confidence should never automatically become factual authority. 19. From AI application to AI ecosystem. This is perhaps the biggest transformation. Initially, the work can be viewed as build an AI application. But the architecture has evolved toward Build an AI ecosystem. That ecosystem contains Brain NeuroGov Plus, Data Architecture AI Intelligence Governance, Registers NG001, 063 Analyzer, Data Points Specialized AI Validation, Sources Cognitive Cube Risk, DFDs OCR/Image Audit, Enterprise Services, Cockpits, Human Decision. 20. The journey is still continuing. The most important point is that Brain NeuroGov Plus is not a finished destination. It is an evolving architecture. The next stages can build upon the existing foundation. Phase 1. Systems Engineering. Phase 2. Structured Analysis. Phase 3. AI Integration. Phase 4. NeuroGov Plus Governance. Phase 5. 3D, 10D Cognitive Architecture. Phase 6. Analyzer 1.0. Phase 7. 63 Specialized AI Engines. Phase 8. Registers. Phase 9. Data Points plus Sources plus DFD. Phase 10. Enterprise AI Intelligence Ecosystem. And this gives us an especially strong architectural principle. Do not abandon the existing architecture every time a new capability appears. Extend the architecture through controlled layers. 21. Dr. Suri's engineering philosophy. The journey can ultimately be summarized by several principles. 1. Structure before intelligence. 2. Data before conclusions. 3. Evidence before interpretation. 4. Specialized engines before uncontrolled AI complexity. 5. Governance before autonomous decisions. 6. Traceability before trust. 7. Validation before acceptance. 8. Human oversight before irreversible action. 9. Reusable architecture before duplicated solutions. 10. Evolution rather than uncontrolled architectural change. 22. The larger vision. The ultimate vision can therefore be expressed as Brain NeuroGov Plus AI. A governed cognitive enterprise architecture that connects real-world data, structured information, specialized AI intelligence, analytics, evidence, risk, governance, and human decision-making into one traceable ecosystem. And perhaps the most important evolution is this. Yesterday, systems processed data. Today, AI interprets data. NeuroGov Plus. AI is governed by data, evidence, relationships, analysis, and human judgment. Brain NeuroGov Plus. The entire enterprise becomes a connected cognitive system. That is what makes your journey with Brain NeuroGov Plus AI much bigger than the development of 63 AI engines. The 63 engines are components, the architecture connecting data points, sources, registers, DFDs, AI, analytics and governance is the real brain. 23 3D, 10D AIDNN engine plus cognitive cube plus analyzer 1.0 plus policy engine plus cockpit. The 3D, 10D AIDNN engine plus cognitive cube forms the cognitive intelligence foundation of Brain NeuroGov Plus. The 3D, 10D AIDNN engine provides deep neural network-based intelligence across multiple dimensions, while the cognitive cube organizes those dimensions into a structured cognitive space where relationships, perspectives, patterns, and interactions can be examined. Instead of treating AI as a single input-to-answer mechanism, this combination supports the progression dimension rightward arrow perspective rightward arrow relationship rightward arrow analysis rightward arrow intelligence, enabling the system to understand complex enterprise information from multiple connected viewpoints. Analyzer 1.0 plus policy engine, set theory, plus cockpit converts that intelligence into governed, usable decision support. Analyzer 1.0 performs structured analysis, metrics, variance/risk and interpretation. The policy engine, using set theory, applies defined rules, relationships, conditions, and policy constraints to determine whether analytical results satisfy governance requirements, and the cockpit presents the resulting intelligence, evidence, risks, explanations and decisions to the user. Together, the architecture can be viewed as AI intelligence rightward arrow cognitive analysis rightward arrow analytical validation rightward arrow policy/governance rightward arrow human decision, making brain NeuroGov plus a governed cognitive system rather than simply a collection of AI models. Dr. Pradeep K. Suri.